work and power, but the first part is about Newton's laws of motion actually. So a car of mass 1800 kg and a trailer of mass 300 kg up a straight road inclined at angle alpha to horizontal, sine alpha is 0.05, connected by a tow bar. There is a force resistance 800 on the car and F on the trailer. The driving force is 3000, F is 100, and we're finding the acceleration and the tension. So we have weight downwards because of the mass 300, mass times g, 3000 newtons is the vertically downwards weight force, and for the 1800 we have 18,000 newtons. We split the W into W cos perpendicular to the slope, W sine parallel to the slope. The W is 3000, this is the value of sine, the W here is 18,000, this is sine, so we have W sine, W cos. Now to find the acceleration, here we can use FBD of all. That's the fastest way to find acceleration. So for the FBD of all, we have acceleration is going up the hill, so sigma F equals ma. For the sigma F, just look at the acceleration direction up the slope. So all the forces in this direction parallel to the slope. If it's going up the slope positive, down the slope negative. So 3000 is going up the slope positive, this 800 is negative, and this 18,000 times 0.05 is negative. And actually we have tension negative, tension positive, but they cancel out anyway in the end. We have the 100 also negative, and the 3000 times 0.05 also negative down the slope. FBD of all, we use the mass of all. Use your calculator, whatever you get on the left, divided by the brackets, we get the A. And to find the tension, we use FBD of car only or trailer only. So here we are using a trailer only because we have one fewer force to consider. So if you look at the trailer, we have 3 forces along the slope direction here. So sigma F equals ma, the T is positive up the slope, the 100 is negative, the 3000 times 0.05 negative, equals ma, trailer mass only. We know the A already, and we can find the T. So in conclusion, the A and the T, we have the final answer. Now this is the energy question. Instead that the total work is 6000 and it's going 50 meters up the slope, 50 meters. So from this 50 meters and this alpha, we know that the vertical distance traveled is 50 times sine, which is 2.5. And we know that the initial velocity is 20 here. And we know that the work done by this resistance force is 6000. And we know the resistance force on the car and the 3000 Newton force of the trailer. Okay, so question is to find the speed of the car at the end of the 50 meters. So first of all, we use energy equation. Energy loss equals energy gained. So since this this system is going up the slope, it is gaining potential energy, is going higher. So for the energy loss, that's because of the engine. We have work done by the engine, so we are losing fuel, energy lost. And because, so we don't know the velocity, whether it's going to be faster or slower. We're just going to assume on top here the speed is smaller, so it's going slower. Going slower means we are losing kinetic energy. Okay, this is just an assumption. If it's wrong assumption, if in the end the speed is actually bigger, so this term will be negative, but the value of the velocity will be still the same. So for the energy gained, it's going to a higher place. We are gaining potential energy, and we have resistance forces like frictions, so we have thermal energy. of the car and the trailer. Now we plug in the values for the work done by the engine. This is the force, the engine force, times the distance, work done by the engine. And for the delta KE, so because this is of all, we use the mass of all. And for the V squared, we have 20, and we don't know the velocity here, that's what we're looking for. So for delta PE mgh, the total mass, G, the H, we have to use the vertical height, which is the 2.5. And for the work done by the resistance force on the car here, so the thermal energy of the car, the resistance force times distance, that's the work done by the resistance force on the car. And the work done by resistance force of the trailer, it's given in the question, it is 6,000. Right, so now we are solving for V squared. Just do the algebra here. So use a calculator, and use a calculator. And actually it is obvious that this term is actually negative. This term is negative, which means the velocity on top would be bigger than 20 actually. Okay, but that's okay. We can just solve for V. We get the same thing in the end. So we subtract 150,000 from both sides, divide by 1050, and then we add V squared to both sides, subtract 1030 over 21 from both sides, and use a calculator, take the square root, we get the final answer. Alright, I'll see you again next time.